Hi, this is Abdullah Muhammad, and this is going to be a video about my Google Summer of Code project. This video will contain two sections. The first section, we will preview the site itself before and after my project and preview the changes that were made. The second section in the video, we will preview some code snippets that I used in the project itself. At last, I would like to thank Google Summer of Code and Circuitverse, my organization, for this great opportunity. And also, I would like to thank my mentor, Mr. Sadvik, for his help and support during the project. And that's it.
Okay, hi again. Now I'm going to preview the changes that are added by me before my project and after my project. To do this, I have these two tabs open. The first tab is the circuit site itself, and the second tab is the site opened locally on my machine. Of course, the changes are not merged yet, so we will be able to observe them. Over here, in both of them, I have the simulator opened with two circuits. First, this is the main circuit, it's empty, and this circuit 2 contains a very simple circuit, one LED and one button that control it. Same thing over here. Main is empty and main is empty. Just a second, let's just play this just for consistency. In circuit 2, just a simple circuit and some elements itself. We will see the purpose of these unconnected elements right now. So now I'm going to enter circuit 2 as a sub-circuit inside main. So insert sub-circuit. Right now I have circuit 2 as a sub-circuit. Same thing over here. And sub-circuit 2. Okay. This is the circuit first site itself. Now this is a kind of a black box. It isn't very declarative, it isn't very helpful. The user doesn't have any contact with the elements inside. He doesn't have any control over them. He can't, for example, use an indicator LED inside to see if something overflowed or some signal is active. He can't do this in here on the site itself. Over here it's still the same. We can see anything. This is just a little bit bigger. Its dimension is larger, but nothing. The user doesn't have any control or anything. Now to change this layout of circuit to circuit, we need to enter its layout mode, and this is where the changes will appear. Okay, here we enter this layout mode. Same thing over here. Circuit 2 and enter layout mode. And now we can observe the first of the changes that I have added. Over here, it's still the list of the all elements itself. This is the site itself. A list of all the elements itself, not any elements specific to circuit 2. It's just a list of all the elements that the site offers. But on my machine, we can see this is a list of the elements that exist in the circuit 2 itself and is allowed by the site to be used as a sub-circuit element, which means that they can appear on the surface of the sub-circuit itself, or the circuit is used as a sub-circuit. So here we have a select segment display. Over here it's a little bit large. Let's list over here. Okay, that's it. We have a digital LED, and if you noticed, this element didn't have a label, so it has this unlabeled thing. But over here, the changed the LED, if you remember, had the label L1 and the button, I think, had B1. These labels are very important to differentiate if the user used a couple of LEDs or something. So the first addition is a list of lists of elements that the user used in his circuit, and the user can pick from them, drag and drop whatever element he wants to view on the surface of the circuit itself. We have a counter. Okay, let's place store here. One thing, the user is allowed to place these elements within the border of the subcircuit. So if by accident I placed it outside, it just goes back in there, and you can see the list refreshes. So it no longer has the counter, as the counter is already placed. So the first thing is over here. The first change is adding the list of all the elements, allowing the user to drag and drop from these elements to choose whether or which elements that he needs to appear on his subcircuit surface. Another thing here, there was nothing over here in my machine. On my machine, there is a properties menu. This properties menu is specific to each element. So if I click on the counter, I can control the properties of the counter. Same thing for LED, same thing for button. So for example, if I needed to change this LED to LED 1, if I needed to make the label disappear, I want the label to appear. Okay, of course that's not what I want. Change the direction of the label. It isn't just these things that are allowed to change, but I can in the future. Any developer could add a property that is specific to the LED, for example, to change it from here, to allow the user to change it from here. So this is the second change, is adding a properties menu that can control the properties of the element within the layout mode. Previously, of course, this wasn't there. So now I'm going to hit save, back to my circuit 2 here. Also I'm going to hit save. Now if we, this is the site itself, if we go to the main circuit itself, remember we used circuit 2 as a sub-circuit, and this is still not very declarative, doesn't give the user any control over his circuit from the outside, doesn't output any information about the values of the elements inside. But on my machine, we can see this has a counter. If the counter value changes inside the circuit, this value will change. The LED with its label, the button with its label. So now this is a huge addition, a huge update. Now the user can interact with the sub-circuit itself, not just as a black box that he doesn't know what's inside. No, he can use an indicator like a LED to see if some kind of a signal inside is triggered, or even keep track of counting something. And another thing is controlling inside, so he can have a control panel of his circuit from the outside, like this button. Remember in circuit 2, this LED 1 over here was controlled by buttons, so whenever it's clicked, this LED is clicked. Same thing in here, this button, this B1, if I clicked on button 1, I can see I can control LED 1. So this is actually like a simple control panel for the user from the outside, and it's very helpful, and these updates will open the gates for many possibilities and many great things for the circuit verse site users to achieve. So this is the third change, of course. The third update is making the user capable of having some simple control panel of the circuit from the outside, and giving him the capability of controlling his circuit, not just having it discrete and not very informative like this. Of course, this isn't only allowed for these simple elements. A user can have a counter or a random number, okay, a button, any kind of LED display or any kind of segment display, he can have it. So whenever this segment display changes inside the circuit, it changes in the outside also. And that's almost it for these changes on the site. Now I'm going to review the changes in the code itself. Okay, this will be the third part of the video. In the previous part, I previewed the changes and the update itself on the site itself, comparing the original site and my local machine site. Over here, I'm going to preview the changes, but in perspective of the code itself. So over here, I have this pull request open. It features subcircuit hash 431. Sorry, excuse me. Okay. It indicates that I have changed 10 files. I'm not going to go through all the details, but just to skim across the code quickly. So over here, just a div element. This is the element that is responsible for the list, for the new list in the left sidebar that indicates the elements. Over here, this is the counter element class or constructor function. It's overriding this property and this property and this property. Each element, most of the elements, inherit from the circuit element class. The circuit element class is the base class for all elements. So each element itself inherits from it and overrides these properties according to its customization and specifications. For example, this represents the dimensions of the element in layout mode or when used as a subcircuit element. So we are going to see these a lot for most of the elements, these properties. And of course, this is the layout draw. It's responsible for drawing the element in layout mode. You can see we are making context and using the subcircuit metadata is the data that of the element when used in a subcircuit. General context, identifying font properties and stuff. Okay, this is some jQuery. Over here, this is the code responsible for the properties menu in layout mode. Remember, we didn't have a properties menu in layout mode in the site itself for now. Now there is a properties menu activated that appears when there is a layout, when layout mode is activated, and according to the last clicked element, we can update its properties. This is in the show properties function. It's actually this isn't very complicated. It's just a bunch of HTML code. Then we are appending it at the end. This is for the check button of the properties. Never mind. Now this is an important function. Fill subcircuit elements is the function that is responsible for filling the elements in the sidebar, in the left sidebar. Circuit element list is a list of all the elements. So we check if the element itself can be shown in the subcircuit. If not, then we continue. If yes, then we check if there is such an element in the user circuit, and according to the user circuit, we print out or append some HTML the same to the sidebar to representing the elements using their labels to differentiate between them. And then at the end we just append the whole thing to this is the ID of the div that we've seen in the beginning of the page. Down here is just an event listeners for capturing if one of the elements is clicked or not, and this is some jQuery function. Over here is when we load data, when we save some project or circuit, we save it in a data structure object, in some object called data. So if we are going to load it again, we need to give each object its subcircuit metadata again by accessing data of subcircuit metadata and assigning it to the object itself. Here is the engine over here, and I think, yes, just a second. Sorry about this. Here we are again. We're at engine.js, yes. Okay, so we go down. This is just some UI. This is about updating the element itself. We just loop over all the element that is selected by the user and updates its value. Over here it's about rendering, changing the rectangle. So yes, over here we render the element by calling it raw layout mode. This function is actually inherited by all elements from circuit element class. So we just loop over them and check for each element we call it. We updated layout node by updating its parameters. Actually, there was something interesting in here. Yes, here there's a comment. Whenever I clicked on a layout node over here, this is a layout node over here. Whenever I clicked it, remember the properties menu printed undefined. So in order to solve this, I updated this object, but the real fix to this, remember we said circuit element is the base class for all elements. The problem here is whoever wrote the code for layout node, it doesn't inherit from circuit element, which is it's bad design because of the consistency. It's not consistent because all elements except the layout node inherit from circuit element class, and because this layout node element doesn't, it lacks some of the function. This leads to its behavior of giving undefined or something. So this will partially repair it and prevent some errors in the console, but mainly the main fix is make it inherit from circuit element class. This is a circuit element class or constructor function over here. Here we're checking if it has a property, if the element has a property that can be shown in subcircuit, we're giving it some object to hold its data. And here we are saving, when we're saving each object, we're giving it this dot, so we're taking the value of subcircuit metadata and saving it, if you remember, in the data object. Here in the starter dragging, we're using if we are in layout mode, we're updating the metadata. If not, we're updating X itself. Release click. It's okay. Here is hover. New label direction. This are what I was referring to in the beginning when I said the circuit element has these properties, and each element after inheriting them overrides them to customize its values. So for example, the counter of course didn't have the same dimensions in layout mode as some segment or something, and these are the properties that appear in the properties menu of each element in layout mode. Of course, if some element has another property that needs to be customized, we need to insert it to override it for the element itself. Okay, draw layout mode. That's a function responsible for just this is just a bunch of code. It's nothing actually. It's just according to the label direction we're drawing the label, we're determining its place and drawing it, and of course checking if the label is allowed in the first place or not. Layout update. This is for updating the element. Over here, this function I received great help from my mentor. It was actually pretty difficult. It contained a lot of code from the update function itself, which is the function that used to update the value or calculate the output of some element in normal mode. Layout update is the one that calculates the output layout mode. I actually received a lot of help writing this function. I believe it was before the first evaluation period. Yes, I remember this part. This is the one responsible for determining if some element lies within the borders of the subcircuit. If not, it just goes back to the menu. If it's placed in the subcircuit within the subcircuit borders, it just stays in there and it's okay. Else it returns. Over here in modules.js, modules contain the constructor functions, the constructor functions for many elements, such as the led or the thing or something, the led, the variable led, or the square RGB. So it will mainly contain the differences will be the same as this. Remember, all elements override this. Only elements that are allowed to be shown have the property, the value of this property as true. Other elements that are not allowed, this property is false or undefined. Same for thing. So the differences in modules.js will just a bunch of elements overriding this, and of course its layout properties, and of course its layout draw function. So it's actually nothing important. Over here is the code responsible for capturing the click on the button. So first we loop over all the buttons that exist in the local scope or the circuit itself, and then we check, this is a matter of efficiency actually, we check if the button is shown in the subcircuit, because of course we don't need to capture a click on a button that is not shown in the subcircuit in the first place. So we're just calculating these for a button that is shown. And then after calculating the mouse coordinates and the properties of the dimension of the element itself, then over here this equation determines whether or not the click is on the button itself. Then we take the index, this is the index of the button itself in the array of buttons, and over here we are changing the property of this specific button to true, that it was clicked. And when this click is released, we just change was clicked to false. Something to note over here that this is hard coded to buttons only. Right now most of the elements except the button don't need to capture any clicks. Of course this will be updated in the future, but currently only buttons need to capture their clicks. We won't need to capture clicks on 7 segments or on LEDs, for example. They would be meaningless. Over here we are drawing element for each subcircuit. For each subcircuit we see if the element is shown in the subcircuit according to its element, then we loop over it. If it's allowed to be shown in the subcircuit, then we draw it, else we don't. And that's it. At the end, I would really like to thank my mentor, Salvik. He was very supportive and helpful during all 3 phases of the program. And of course, thank Google for it, for this great experience. It was awesome, actually. Very informative, very helpful, pushed me a lot forward. I gained a lot of insight about open source and about contributing, and used a lot of GitHub stuff that I really didn't use in real life before, and knew the true use of them. And that's it. Thank you. Bye bye.